Hi, my name is Lauren Shum, and I'm a junior at Duke University. I study electrical and computer engineering, and I think empowerment is all about lowering barriers to entry. Nobody should have to face any undue challenges that result from their socioeconomic differences, or from their gender differences, or from their racial differences. None of these should exist, and I think empowerment is about eliminating the factors that prevent people from these backgrounds from achieving their goals. So to start, I'm going to talk about an analogy using electrical and computer engineering. So this here is a diode. A diode is an electrical component that allows current to flow in one direction. Electrons want to enter a diode and come out the other end. Now, there's two different operating conditions for a diode. There's forward bias, and yes, this is the actual term that's used in electrical engineering. There's forward bias and reverse bias. Under forward bias, we're applying a voltage in the forward direction. A voltage is like a force that pushes electrons through a wire. So here in this battery, the voltage is applied from here to here. So the current is going to want to flow out the positive end and through the diode. Because the voltage difference and the diode are aligned in the same direction, forward current is allowed to flow. And the reason this is true is because when we apply this forward voltage, we're actually lowering the energy barrier that is implicit inside the diode. So the diode has a barrier that kind of looks like this when you draw it out. Electrons want to go from this lower energy side to this higher energy side. And in order to do that, they need to jump this gap. But the energy barrier from a diode that's not inside a circuit is too high for them to do this, so no current is allowed to flow. When we apply this voltage, however, we make this energy barrier a lot smaller, and all of a sudden, the natural variations in the electrons will allow them to jump over this energy barrier and flow through the diode to the other side. Now, of course, the opposite condition, as I mentioned, is reverse bias. And under this condition, we have the battery attached in the opposite direction. Now when current wants to flow out of this positive end, it encounters a backward-facing diode. The current wants to go this way, but the diode is positioned to allow current to go this way. And because of that, no current actually flows in this diode at all. And the reason this happens is for the opposite reason that forward bias allows current to flow through in the positive direction. If we take this picture here, which is the resting energy of a diode, what happens when we apply the reverse bias is we're increasing this energy barrier. The electrons couldn't even get over this small barrier without the voltage applied backwards. But the moment we apply a backwards voltage, it's greatly increased, which greatly reduces the ability for electrons to pass through. And if we make this difference large enough, what happens is the diode will actually break down. It will break down and allow current to flow in the reverse direction. The electrons will be entering the diode backwards and flowing backwards out the other end of it. So what does all of this mean? So I'm saying that empowerment is like forward biasing. We want to lower the barriers for entry. We want to allow electrons to flow in the positive or forward direction. We want women to move forward and advance in their careers. We want them to join the workforce. We want them to make economic gains. But women can't do that if there are social forces that are impacting them and preventing them from striving forward in this manner. If we're able to eliminate barriers that stem from gender differences, racial differences, and socioeconomic differences, then we have succeeded in empowering people.